So today we're going to be doing clearing a fraction. And so one of the things that students see when they see equations with lots of fractions is we could go ahead and we could go through the rules on fractions. But I think a more convenient way, especially when we hit systems of equations, is to go ahead and just get rid of them. Especially if you have an equal sign, there's no reason we need to keep them explicitly. And so the rule to do that is we're going to multiply the entire equation by the LCM of all the denominators, and it's going to get rid of all these fractions. So without further ado, let's go ahead and jump into number one. So with number one, what we're going to do is I'm going to list all of these denominators. Let's do this in red. Okay, so I'm going to list, I have a 10 and a 5. And I'm going to list all multiples of 10 and 5 here real quick. So I got 10, 20, 30, 40, 50, 10, 15, 20, 25. And I'm going to go ahead and I'm going to find the least common multiple between the two lists. And what you notice is the least common multiple is a 10. Okay. Now I could do it with a 20 because I notice a 20 is in both lists and there's nothing wrong with it. But if I use a 10, it's going to keep my numbers the most manageable that I can. I could go higher, but my numbers are going to get bigger. Nothing wrong with it. It's just going to make it a little more cumbersome. So my LCM is that of 10. So what I'm going to do is I'm going to take this equation, I'm going to put it in brackets to show that I'm going to multiply the entire thing by something, and I'm going to multiply everything in this equation by the number 10. Perfect. And so when I distribute this 10 into the equation, each term, the 1, the 1/5, and the 1/10, all get multiplied by 10. And so 10 divided by 10, this is going to end up being 10 times 1 divided by 10, 10 times 1 divided by 5, and 10 times 1. So why don't we look at the division part first? I'm going to ignore the times 1 and just say what is 10 divided by 10. That's going to give me a 1. So I'm multiplying this first term by 1. The next term, I have a 1/5. So I'm going to say what is 10 divided by 5? 2. So I'm multiplying the second term by 2. In the third term, there is no fraction. So you could either think of it as a 1 over 1, or you could just know that I have to multiply the full force of 10 into this part of the equation. So 10 divided by 1 is going to be 10, which is why I get the full force of 10 right there. And now I look at 1 times 1 is going to give us a 1x, 1 times 2 is going to give us a 2, and then 10 times 1 is going to give us a 10. Lo and behold, this equation no longer has fractions up front. The answer can still be a fraction, but you don't need to deal with that until you go through the final division process where we get rid of the coefficient. Awesome. And then for the rest of this, we just simply go through and solve. So I'm going to subtract 2 from both sides, and that's going to leave me with x equals 8. Boom. There we go. So not too bad. If we look at number 3, we're going to see something very similar. I'm going to list all of my denominators. In this case, I have a 15 and a 5. I'm going to list a few multiples. You don't need to list a lot of these. Sometimes you can just spot them right off the bat, but I'm going to go ahead and I'm going to list a few. 15, 30, 45, 60. I got 5, 10, 15, 20, so on and so forth. And what I notice is at that point, I have my least common multiple. It's going to be 15. And so I'm going to take this entire equation and multiply it by a 15, which means I take 15 times 1 divided by 15, 15 times 1 divided by 5, and 15 times 1. I'm not going to look at the multiplication process right now. I'm going to look at the division process and say 15 divided by 15 is 1. I'm multiplying this term by 1. 15 divided by 5 is 3. I'm going to multiply this term by 3. And then again, I see a whole number, so I know the whole number is understood to be over 1. Regardless of what it's over, though, I know that the 15 divided by 1 is going to be the full force of 15. So I'm going to multiply that by everything. And my next line equation is going to give me a 1x minus 3 is equal to 15. Perfect. Now that makes it much more friendly to go ahead and solve. Let's add 3. So I'm left with an x equals 18. Perfect. Okay. And so on the next one, what we see is, unlike the previous two, I don't have a common denominator amongst these. We noticed with the previous one, the common denominator, or the least common multiple, was 15. It was one of those denominators. Like this one, it was a 10. It was one of the denominators. With this one, we don't have that. 2 isn't a multiple of 5, and 5 isn't a multiple of 2. So we're truly going to have to use our list here. So I have a 2 and a 5, which means 4, 6, 8, 10, 12, 14, 10, 15, 20, 25, so on and so forth. What we notice in both those lists, we see the common number of 10. So I'm going to multiply everything by the number 10. Now 10 isn't going to be the final result of what I'm multiplying everything by. I'm going to go through and I'm going to say 10 times 7 divided by 2, 10 times 1 divided by 5, 10 times 1 divided by 2, 10 times 61 divided by 5. But as opposed to getting the big numbers and then going through division, we can go through piece by piece and say 10 divided by 2 is 5 and simply multiply by 5 and be done with it. We can take 10 divided by 5 is 2, 10 divided by 2 is 5, and 10 divided by 5 is 2, and multiply by these smaller values, and we get to keep those. So the 5 times the 7 is going to give me 35x. 1 times 2, negative 1 times 5, and then 61 times 2. Oh, don't forget your x right here. 61 times 2 is going to give us a, let's see, 122. Perfect. So I have this, and I'm going to go through and I'm going to solve the equation, which means I see an x on both sides. I need to either get rid of this or get rid of this. I'm going to get rid of the negative 5x by adding it, which means I do the same over here. It, in effect, gets rid of that term. So I have 40x plus 2 is equal to 122. Now that my x's are all together in one spot, I need to get rid of the non-x terms. I need to get rid of that plus 2. So I subtract it, which means I do the same over here. That, in effect, gets rid of that term. So I'm left with 40x is equal to 120. Now that my term is isolated and all my x's are nice and tight right there, I'm going to go ahead and I'm going to get rid of that coefficient by dividing by 40. And I'm left with an answer of x equals 3. Perfect. And so that's going to bring us to the next set of questions. Let's zoom in on number 7. Okay. So what I want you to try is you just saw one of those. Why don't you go ahead and try and identify the common multiple and then clear that fraction real quick. Unpause the video when you're done and see how well you did. Okay. Now that you've had a shot to try it out, what I see is I see different denominators of 2 and 3. So I'll count by 2s and count by 3s. 4, 6, 8, 10, 6, 9, 12, 15. And I notice that my common multiple is going to be a 6. So now I go through here and I multiply everything by a 6. Let's just separate that. So that way we visually know that that's not what's going on over here. Okay. So as I go through and I multiply everything by 6, it's 6 times 3 divided by 2, 6 times 35 divided by 3, 6 times 1 divided by 2, and 6 times 25 divided by 3. But as opposed to going for these large numbers here, I'm going to stick with the smallest possible, and let's start with division first. So 6 divided by 2 is going to give me a 3. 6 divided by 3 is going to give me a 2. 6 divided by 2 is 3. 6 divided by 3 is 2. And I'm going to multiply each one of these terms by that value instead. So 3 by 3 is going to give me a 9x. 2 by 35 is going to give me a 70. Negative 1 times 3 is negative 3x. And then plus 50. Perfect. So now I can go ahead and I can solve this equation, which means I see x on the left and the right. I'm going to go ahead and combine this by getting rid of this 3x over here, which means I need to do the same thing to the other side, and in effect gets rid of that term. So 12x minus 70 is equal to 50. Now that my x's are combined, I'm going to get rid of the non-x term by getting rid of that minus 70, which means I add a 7 to the other side. That, in effect, gets rid of that term. We don't really care what it does to the other side as long as we get rid of it on the side that we don't want it. I know oftentimes I use and other people use the descriptions of moving it to the other side. We are and we aren't. I'm not moving the 3x or the negative 3x over here. I'm getting rid of it on the right-hand side, which means that it shows up on the left. So hence the move, but really I'm just getting rid of it over here and I'm saying whatever happens over here happens. I just don't want it on the left. Same thing with this 12. I don't want to be multiplied by x, so I'm just going to get rid of it by undoing it by dividing by 12. I don't really care what happens over here. I just want to get rid of it on the left, and I have to be equal, so I do the same thing on the right. So x equals 10. And there we go. Perfect. So let's see, we got one more right here that we're going to walk through. Now with this one, I have 3 separate denominators. I have a 3, a 5, and a 15. So no matter how many different denominators you have, I still go through the exact same process and I write out multiples. 6, 9, 12, 15, so on and so forth. 10, 15, 20, 25, 30, 45, 60, 75. And I try and find the smallest one in all 3 lists now. What you'll notice is that 15 is the common number in all 3 lists. You might need to go a ways out. You might even need to come down a second row if they're not obvious or quick. But it's the exact same process as before. So I multiply everything by a 15. And again, I could say what is 15 times 2 divided by 15, 15 times 2 divided by 5, 15 times 4 divided by 3. Or I could just go through the simple process of dividing first. 15 divided by 15 is 1. Divided by 5 is 3. Divided by 3 is 5. And then only multiply by these reduced values. It's going to give me a 2x plus 6 is equal to 20. Awesome. So now I get to solve this. Now I'm going to get rid of the 6 on the left by subtracting 6. And I need to be fair, so I'll subtract 6 on the right. So it gives me a 2x is equal to 14. Then I want to get rid of the times 2 by dividing by 2. And I'm going to be fair and do the same thing to the right-hand side, which gives me x equals 7. Perfect. Okay. So now what I want you to try is I want you to try the last one. Go ahead, pause the video. Try this one start to finish. Unpause it when you're done and see how well you did. Okay. Now that you've had a chance to try it out, let's check this. So I have... Let's see, I'm going to do this, 3, 11, and 33. So for 3, I get 3, 6, 9, 12, 15, 18, 21, 22, 33, 44, 55, 66, 77, 66, 99. Let's see, that's 102, 102. Plus 30 is going to be 132. I don't know why that was so difficult to do. 135, 165. And I really don't want to go any higher with the 33s because I notice 11's going pretty high, but I don't have anything in the 3s just yet. So my 3s, I'm going to come down again. 24, 27, 30, 33. And that's where I see my third number. I see 33 in all 3 of my lists. Even though my 3, I had to come down and continue on with my list. So I'm going to multiply this entire equation by 33. I'm going to go through, instead of multiplying 33 by 4, 33 by 4, and 33 by 4, and then doing the division, I'm just going to say 33 divided by 33 is 1, divided by 11 is 3, divided by 3 is 11. That'll give me the brand new equation of 4x minus 12 is equal to 44. A much easier equation to deal with. As I slide down right here, I'm going to get rid of this 12, which in effect cancels that out. So I have a 4x is equal to, let's see, 46, 56. Now that I have that, I'm going to get rid of the 4 by division, which in effect cancels that out on the left, and I get x equals, let's see, 4 fits into 5, 1 with 1 left over, 16, it fits in 4 times. So I get x equals 14, and there we go.